Welcome back. So this is the second part going through this question right here. In the first part, I spoke about how we can use our CAS calculator to answer this question. And now in this part, what we're going to go through is how we could answer this question by hand, which is going to be a bit more involved. If you haven't, go back and watch that first part, because in that first part, I also spoke about how we can just get a sense of what this graph looks like and how we can use all of this information here just to give ourselves a bit of a sketch. And of course, the important information that the maximum value is 18 as well. So go back, watch that, and you'll just get a sense of how we can know what we're looking at and just what all of these pieces of information are. All right, we're just going to jump straight in doing this by hand. And what I want to first do is just write out what I know about both of these functions. I know that they have the same y-intercept, which is 0, 10. I know they have the same x-intercept, which is 1, 0. I know that they have the same maximum value. Now, I don't know the value of x for the maximum value, but I know that the maximum value is 18. What I'm now going to do is use each of these pieces of information to figure out what the quadratic rule is going to be. I'm going to use the general form of the quadratic rule that looks like this: ax squared plus bx plus c. And what I'm going to do is I'm going to use each of these pieces of information to help me solve for a, b, and c. All right, first things first, can you tell me what this c is telling me? That c is telling me the y-intercept. And I know what the y-intercept is. The y-intercept is 0, 10. It's that piece of information right here. So that means I can immediately replace this c with a 10. And I'm using that piece of information there. Once I've used it, I can't use it again because I've used it to figure out what c is, so I can't use it again. Then we move on to the next piece of information, 1, 0. So that is using the fact that I know that both of them go through the same x-intercept. So what I'm going to do is I'm going to sub in 1, 0 here. So that means I put a 0 here, a1 squared plus b1 plus 10. That means I'm going to be left with negative 10 is equal to a plus b. That is one equation that we have. We're going to create simultaneous equations here. So we've just first created our first one. So let's label that 1. And I've used that piece of information now. Now, what I'm going to do is I'm going to sub in this point to create another simultaneous equation. So let's do that. I have the point, so I'm going to sub in x18. That would leave me with 18 is equal to ax squared plus bx plus 10. I could minus 10 from both sides, which will leave me with 8 is equal to ax squared plus bx. Now, the issue is here is you see how this is in terms of a and b, but this is in terms of a, b, and x. What I need to do, and this is the tricky part, I need to get rid of this x, or I need to replace it with something so I can have this all in terms of b and a, or a and b. You might like to pause the video and think about what we could replace this x with. And it has to do with what the x means. Look over here. What is this x telling me about this and this? What is it telling me? Do you see how they're both the midpoints? They're both the midpoints. And I know that the midpoint is negative b on 2a. So that means what I can do is I can replace the x with negative b on 2a. And you see what happens when I do that. When I do that, so I'm replacing the x with negative b on 2a plus b, negative b on 2a. Do you see how now I've got it all in terms of a and b? It's no longer in terms of x anymore. And that's what I wanted, because at the end I want two simultaneous equations which are both in the same terms. Now that is, I would have to say, the tricky part of that question, realizing that right there. But it's something you need to get good at, kind of thinking outside the box and like, all right, what is actually happening here? That's the beautiful thing about methods, being able to critically think about things. All right, let's continue on now. Now we're just going to get lost in the algebra for a bit, but we'll enjoy it. Oh, and also this is being squared. Don't forget that, because that's squared there. All right, that's going to be b squared over 4a squared. This is going to be negative b squared over 2a. Okay, we're doing well. Now, what's going to happen here is that this a will cancel with one of the a's down there. So I'm going to be left with b squared over 4a minus b squared over 2a. If we're subtracting fractions, I need to make sure that they have the same denominator. So I'm going to times the top and bottom by 2 here. And that's going to leave me with, we keep on going. This isn't necessarily hard now. It's just a bit laborious, which is a great word, don't you think? Laborious. This is 4a. All right, that means I'm going to get 8 is equal to negative b squared on 4a. We continue on. That means I'm going to get 32a is equal to negative b squared. And then I'm going to say b squared is equal to negative 32a. Okay, perfect. I'm going to call this equation 2. Now, this is where we again need to critically think. So if we're like looking through this and really identifying the parts where we need to really think about things, I would say one of them is definitely this right here, recognizing that x is negative b on 2a so that we can create an equation in terms of a and b. And now we're going to have to think again. We've got two simultaneous equations here. We've got this and we've got this, and we have to solve them. What are we going to do? Remember the different ways of solving simultaneous equations? You can do it by elimination or substitution. Elimination, not a great move here. Well, what I could do, and again, this is where the critical thinking comes into play here. I know that this is b squared is equal to that. It's b squared is equal to that. Could I rearrange this to get it into b squared is equal to something? And I could. I could say that this is negative 10 minus a is equal to b. So I've just moved that a over. And then what I could do is I could square this and square that. And that's going to leave me with, now if I write this out nicely, it'll be a plus 10, and that's all squared, is equal to b squared. So what happens is when the negatives just go away because we're just squaring it. So we've got a plus 10 all squared equals to b squared. And this is really what I'm going to use for a now. This one right here. Oh, so for 1 rather. Because what I can do now is I can say equate 1 and 2. And now let's just zoom out here and just appreciate what I'm saying. B squared is equal to this. B squared is equal to that. So that means what I can do now is go this a plus 10 squared is equal to negative 32a. Negative 32a. I've equated 1 and 2 together because they're both equal to b squared. All right, we zoom in. This here, when I expand it, will become this. So I'm just expanding out that quadratic. Negative 32a. I would then bring this negative 32a on the other side. A squared. 20 plus 32 is 52. Plus 100 equals 0. Then, can I factorize this? I absolutely can. What are the two numbers? The way I like to think about this is I need two numbers, the product of which is 100, the sum of which is 52. What factors would achieve that? Well, it will be 50 and 2, because 50 times 2 is 100, 50 plus 2 is 52. That's called the PSF method. Or you might just be able to look at that and identify it. So I'm going to get a plus 50, and then a plus 2 is equal to 0. That means I'm going to get a is equal to negative 50, and a is equal to negative 2. All right, we're getting close here, people. We're getting close. We got this, and we got that. If I now want to figure out what b is, what I can do is sub it back into my original equation. Now, I would sub it back into this one right here, because that's the easiest one to sub it back into. Negative 10 is equal to a plus b. So if I come here, I'm going to say sub into negative 10 is equal to a plus b. That's what I'm going to sub it into to find my answer. And let's just double check I wrote that correctly. That was correct, wasn't it? Yeah, negative 10 is equal to a plus b. Okie-dokes. So if I go, I'm going to sub in a is equal to negative 50, which is going to be negative 10 is equal to negative 50 plus b. So that means I'm going to get b is equal to 40. Therefore, a is equal to negative 50 and b is equal to 40. And then on this other side here, I'm going to sub in a is equal to negative 2. Negative 10 is equal to negative 2 plus b. That means that I'm going to be left with, when I plus that over, negative 8 is equal to b. So I'm going to come here now and say, therefore, when a is equal to negative 2 and b is equal to negative 8. All right, we're nearly done, people. We're nearly there. We're just going to continue going on here because this is really the important stuff. This right here and this right here. Because remember, you're probably, it's been so long since we talked about it. Feels like this question's been going on forever. The whole point was we're trying to figure out what A and B are. That was the whole point of doing everything. And now we know what they are. We know that it's this and this. So what we're going to do is we're just going to replace the A and B there. So if I come here now, what I'm going to say is that f of x, and I might even do this in different colors. I'm going to say that f of x is equal to negative 50. Oh, that's ugly. X squared plus 40x. Then it was plus 10. So that's one answer. And then my other answer will be g of x, because remember that's the notation that they used, is negative 2x squared, negative 8x plus 10. And those, people, are my answer. We're done. That is my answer, and that is my answer. All right, I just want to pause for a moment and just kind of reflect on everything that we did and kind of spot out the difficult things that we did. But those are the answers that we're after. And it really doesn't matter which one you called f of x and g of x here. So as you can see here, negative 50x squared plus 40x plus 10, and then negative 2x squared minus 8x plus 10. We got it. Perfect. I was just double checking the answer there. All right. So as you can see, we created two different quadratic rules that both go through these intercepts and have a maximum of 18. If I was to point out the tricky things that we did here, this was a tricky part in which we identified that x is the same as negative b on 2a. And then the other tricky part that we did was equating them. So realizing, hey, I've got this equal to b squared. What I'm going to do is take this equation here and turn it into b squared so that I can equate them with each other, which then allows me to solve them. Pretty tricky stuff, but really good, a really great question just to kind of strengthen your ability. This is a part of what methods is, being able to think through complicated questions in different ways. So hopefully you enjoyed these videos. Remember, in the first part, I went through how to use your CAS to answer it. So it's important that you know how to do it by hand and the CAS. And the more of these questions you do, the better you become. The Cambridge is really great at providing these very high quality questions. That's why we use their textbook, and that's why we want you to do the questions. Hopefully you found this video helpful. If you ever want me to record another video, just reach out. I'm happy to do it. And that took me 14 minutes. Wow. All right. See you, everyone.